So welcome friends and welcome to the Agrico channel. So today we will discuss about the scheduling of irrigation. ये irrigation वाटर मैनेजमेंट चैप्टर का एक बहुत बड़ा इंपॉर्टेंट चैप्टर है. उसमें पहले समझेंगे शेड्यूलिंग मतलब क्या होता है. So scheduling means you have to, there are three W. We can say when to irrigate, how to irrigate and how much to irrigate. These are the three questions. So here in case of scheduling of irrigation, we have to calculate or we have to find out when to irrigate. We have to find out when to irrigate. And this question is depends upon the amount of water you require. Another is the time of irrigation. Okay. And this amount of water to irrigate and time of irrigation, this depends upon two things. One is based on crop need. That means, as you know, that there are some crops which will require less amount of water, like which are drought resistant crops. Okay. And there are some crops which are requiring more amount of water. For example, rice, sugarcane, they are requiring more amount of water. So based upon the crop need, and as you know that in a crop, in any crop, there are different growth stages, and according to the different growth stages, the water requirement is also different. So first one is for a scheduling of irrigation, हमको क्या चाहिए बेस्ड ऑन क्रॉप नीड, एंड अनदर इज वाटर अवेलेबिलिटी. अगर हमारे पास वाटर अवेलेबल बहुत ज़्यादा है तो दैट मीन्स वी कैन अप्लाई वाटर एट एनी स्टेज ऑफ द क्रॉप और एट एवरी स्टेज ऑफ द क्रॉप. बट इमेजिन if we have less amount of water, that means you have to follow certain criteria of scheduling of irrigation. So now we have to go for criteria of scheduling irrigation. There are four different criteria of scheduling irrigation. First one is सॉइल मॉइस्चर बेस्ड अप्रोच, जिसमें हम सॉइल में कितना मॉइस्चर होता है उसके बेसिस में हम इरिगेशन देंगे. क्योंकि अगर आपको पता है, अगर आज हम इरिगेशन दे रहे हैं तो डे बाय डे क्या होगा, सॉइल में वाटर कंटेंट डिक्रीज होता जाएगा. सो अकॉर्डिंगली बेस्ड अपॉन द सॉइल मॉइस्चर कंटेंट आई हैव टू अप्लाई द नेक्स्ट इरिगेशन. शेड्यूलिंग मीन्स व्हाट, अगर आज मैं इरिगेशन दे रहा हूँ तो नेक्स्ट इरिगेशन हम कब देंगे, दिस इज कॉल्ड एज द शेड्यूलिंग और टाइम टेबल ऑफ irrigation. Okay, so next one is climatic approach. So that means climate, as you know that अगर हम सोचेंगे कि ड्राई क्लाइमेट है, वी हैव टू कंडीशन. वन इज ड्राई क्लाइमेट और वार्म क्लाइमेट, another is cool and humid climate. As you know that in dry climate more evaporation loss will be there, as well as more transpiration loss of water will be there. So in this case the irrigation gap, the first irrigation and second irrigation gap will decrease in case of dry climate, because as you know that more loss of the water, hence there will be frequency of irrigation will be more. That means the gap between two irrigation will be less, that means the frequency of irrigation will be more. But imagine if your climatic condition is cool and humid climate, that means in this case the evaporation loss is less, as comparatively simultaneously the transpiration loss is also very less. So in this case the gap between two irrigation period will be more, that means the frequency of irrigation will be less. So in this case the climate based you have to find out basically based upon the evaporation approach. Then coming to plant indices, this is very simple. As you know that as the water content in the soil is decreasing, that means the water content in the plant is also decreasing, and the symptoms or like wilting symptom will be given by the plant. So here these are the three approach, and at last we will go for the some simple technique which is practically a practical approach, and it can be done by the farmer very easily. Okay, so first coming to soil moisture based approach. सॉइल मॉइस्चर बेस्ड अप्रोच में हमको क्या चाहिए, सॉइल में कितना मॉइस्चर है हम उसको देख के हम क्या करेंगे, इरिगेशन करेंगे. दैट मीन्स फर्स्ट वन इज थ्रेशोल्ड मॉइस्चर कंटेंट. थ्रेशोल्ड मीन्स एज यू नो दैट डे बाय डे द सॉइल मॉइस्चर कंटेंट इज डिक्रीजिंग, डे बाय डे सॉइल मॉइस्चर डिक्रीजिंग. बट यू नो दैट सपोज आई हैव टू टाइप्स ऑफ क्रॉप, वन इज wheat and another is sorghum. One is wheat and another is sorghum. That means what do you mean by threshold moisture content? The moisture content of the soil below which the growth of the crop will be affected. Okay, that means the threshold moisture content is that moisture content below which the crop is affected. And as you know that the wheat and sorghum, between wheat and sorghum, which one will need more amount of moisture content of the soil, or which one is more moisture sensitive crop? Sir, wheat is more moisture sensitive crop. That means the threshold moisture content for wheat is more, whereas the threshold moisture content of the soil in case of sorghum it is less. So first of all you have to find out the threshold moisture content which vary or which is different from crop to crop. Okay, so first you will decide it and accordingly you will apply. That means first of all, सपोज इन केस ऑफ थ्रेशोल्ड मॉइस्चर कंटेंट, सपोज आज मैं इरिगेशन दे दिया तो उसके बाद हमको पता है कि डे बाय डे द वाटर कंटेंट इन द सॉइल इज डिक्रीजिंग. सो इन दिस केस व्हेन द moisture content will reach the threshold value, when the moisture content will decrease and it will reach the threshold value, at that time you will go for the next irrigation. Then coming to, अगर हमको moisture content of the soil नहीं पता है तो हम क्या करेंगे? एक मैनुअल अप्रोच है, एक प्रैक्टिकल अप्रोच है, जो कि फिक्स टाइम इंटरवल, एक इंटरवल टाइम हम फिक्स कर देंगे कि सपोज हमको वाटर व्हीट है, दो क्रॉप लिए थे हम, एक है व्हीट एक है sorghum. Suppose wheat is more water sensitive stage. So in this case, suppose in case of wheat, the gap will be, suppose as it is more sensitive, suppose the gap will be 7 days. Suppose in this case the gap will be 7 days. But in case of, suppose it is sorghum, so in this case the gap will be more. Suppose it is 15 days. As you know that the sorghum is a drought resistant crop. That means the interval between two irrigation period. So the interval between two, this is first irrigation period and this is first irrigation period. Suppose this is my second irrigation period. So in this case, in case of wheat, as it is more sensitive crop, hence the interval will become less. But as it is sorghum, which can resistant crop, so the interval between two irrigation period will be more. Okay, so now this is based upon the soil water content. Then coming to depletion of available soil moisture. Again you can say this soil water content is different for different crop, as well as it is also different for different soil texture. As you know that the sandy soil, the water holding capacity is very less. In this case the frequency of irrigation will be more, but in case of clay texture soil the water holding capacity will be more, hence the frequency of irrigation will be less. So next, coming to second point, depletion of available soil moisture. And in this case, first of all you should know what is the meaning of available soil moisture. As you know that in the soil system, if we will see different soil moisture constant, there is two moisture content constant. One is field capacity and another is permanent wilting point. As you know that the range between field capacity to PWP is known as available soil moisture range. And in this case, if I will ask you which one is the upper limit of available soil moisture, sir, this is my upper limit of available soil moisture, whereas this is my lower limit of available soil moisture. That means upper limit of soil moisture means whatever the moisture present at field capacity, suppose 100% water is available, and whatever the water present at PWP, suppose here 0% is available. Okay, so this is available soil moisture is from field capacity to PWP. Okay, so now depletion means what? Depletion means decrease of available soil moisture. As you know that सपोज आज मैं इरिगेशन कर दिया तो मेरा अवेलेबल सॉइल में से कहाँ पे होगा? आफ्टर 2 to 3 days, you know that field capacity will be there. After, remember, after irrigation, if your soil is under saturated condition, after 2 to 3 days, all the macropore water will go downward because of force of gravity. That is why the macropore water is called as gravitational water. Very simple. After the drained out of the gravitational water or macropore water, whatever the water remaining in the soil, it is present in the micropore, Hence, all the micropores are filled with water. Then the point is called as the field capacity. Suppose depletion means what? Depletion means decrease of the available soil moisture. That means suppose I have taken two examples. Suppose one is tobacco. Tobacco, in this case, we are applying irrigation when there is 25% depletion of available soil moisture. Okay, so that means in tobacco you have to schedule the next irrigation. You have to schedule the next irrigation when there is 25% depletion of available soil moisture. That means here this is my 100% available, 25% depletion up to this point. When you for this tobacco, when the depletion will be from 100% to 75%, that means 25% depletion हो गया. Okay, so either you can say that there will be 25% depletion of available soil moisture or 75% of present available soil moisture. In this case, tobacco will next irrigation will be provided. But in case of sorghum, as you know that there will be 75% depletion of available soil moisture. In this case, we will go for next irrigation. So now coming to sorghum. So here it is my field capacity and there will be 75%, that means up to this point. So 75% depletion, or we can say whenever there is 25% available soil moisture, we can go for the next irrigation. So now in this case, you can say, sir, which one is more water sensitive crop and which one is more drought resistant crop? Very simple. In case of tobacco is only very less depletion, that is 25% depletion will be there and we are going for next irrigation. That means the tobacco is a moisture sensitive crop, hence the frequency of irrigation in case of tobacco will be more. So if your less depletion of available soil moisture will be there, then the frequency of irrigation will be more. Okay, so if more depletion of available soil moisture, then the frequency of irrigation will be less, like in sorghum. Okay, next coming to under soil moisture, last one is the soil water potential or soil moisture tension. In this case, as you know that in case of if in the soil system the water content will decrease, then the soil moisture tension will increase. Okay, this is the formula. If water content in the soil is decreasing, then the soil moisture tension is increasing. And now the condition is, which instrument will measure the soil moisture tension or soil water potential? Okay, sir, there is a instrument which is called as tensiometer, and as you know that by using the tension, suppose as हम irrigation किए हैं, in this case, so today the soil contains water, as it contains water, उसका टेंशन क्या होगा? बहुत लेस होगा, कम होगा. So if water content is high, then obviously the soil moisture tension value will be less. Okay, so if water content is decreasing, then the soil moisture tension is increasing, and this soil moisture tension is measured by the tensiometer. But the demerit of this tensiometer, as you know that it can measure up to minus 0.8 bar soil water potential. That means it is only applicable for the coarse texture soil, or which is called as sandy soil. As you know that the tensiometer is used for the sandy soil, because in sandy soil most of the waters are held within a less tension value. Okay, so with very less tension, more amount of water is held in the sandy soil, because you know that less number of micropore is present. Okay, so next coming to, so as you know that this tensiometer is also used for orchard and vegetable crops. Hence this soil water potential or soil moisture tension approach is mostly followed in case of orchards and vegetables. Okay, so now this is based upon the soil moisture. Next coming to climatological approach. मैंने पहले बोला था climate means what? Based upon the evaporation loss, because you know that there are two conditions हम लिए थे. One is dry climate, another is humid climate. In case of dry climate, more evaporation loss will be there, more transpiration loss will be there. So soil में water loss क्या होगा, more repeatedly or more frequent loss of the water will be there. अगर water loss होता है तो क्या होगा, frequency of irrigation बढ़ जाएगा, increase in frequency of irrigation if evaporation loss will be more. Same just opposite, if your climate is humid, that means in this case evaporation loss is less, hence the frequency of irrigation will be less because the duration or the gap between two irrigation will increase in case of humid condition. Okay, so now in case of climatological approach, first of all the thing is that you have to measure the evaporation loss. Okay, so first method is can evaporimeter method. So in this case, can evaporimeter means, first of all you should know the can. The can size is, normally we will take a can where the height of this can is 14.3 centimeter and the diameter is 10 centimeter. Okay, and there is a pointer which is just 1.5 centimeter below the brim. Okay, this is my pointer. First of all, this is the can. Okay, so now in my crop field, you know, there are the different crops and you have to install this can. You have to install this can which is at the same height of the crop. That means the height of installation of the can and height of the crop remains same. Okay, this is the condition. And now you know this, there is a pointer. Suppose in this case the crop is there and you have applied your fast irrigation. हमको पता है कि सर इरिगेशन देने के बाद क्या होगा. सपोज माई सॉइल इज बिकम्स सैचुरेटेड कंडीशन. Saturated condition means the maximum water holding capacity of the soil where all pore space, that is all micropore as well as macropore, are filled with water. Then after some time you know that the macropore water which is loosely held by the soil, this macropore water will go downward because force of gravity, and the remaining water is called as the micropore water, and the point is called as field capacity. So after fast irrigation, so after saturation, after 2 to 3 days, we will reach field capacity point. Field capacity means when all micropores are filled with water. So when we will reach the field capacity, we will apply water or we will pour some water in this can. Okay, so कब कैन में कब पानी देंगे, जब हमारा सॉइल में क्या आएगा, फील्ड कैपेसिटी आएगा. सैचुरेशन आएगा तब नहीं, जब फील्ड कैपेसिटी आएगा तब हम क्या करेंगे, इस कैन में पानी देंगे. ओके, पानी देंगे अप टू दिस पॉइंटर लेवल. सो वी विल फिल दिस कैन up to this pointer level when my soil reach field capacity point. Okay, so now suppose this is wheat crop and suppose this is sorghum crop. As you know that wheat crop is more sensitive, hence predetermined. So there will be a mark. This is for wheat and this is for sorghum. So predetermined mark will be there. We have to previously determined. If it is a wheat crop, then this is my mark. If it is sorghum crop, then this is my mark. So predetermined marker will be there. So if it is wheat, so now as you know that when the soil will reach field capacity, we will fill the can up to this pointer level, and you know that day by day the moisture content will decrease from the can by means of evaporation loss, and now the water content will decrease up to this point. If the moisture content will decrease up to this point, then go for irrigation in case of wheat, and if this moisture content will decrease up to this point, then go for irrigation in case of sorghum crop. Okay, it is very simple. Can evaporimeter, only you have to remember the height 14.3 centimeter and the diameter is 10 centimeter. Okay, so this is the thing. Then coming to most important approach, which is called as IW by CP ratio method. What do you mean by IW? IW means irrigation water depth. अभी तक जो भी पढ़ लिए इसमें, अच्छा इरिगेशन कितना देंगे. सपोज इन दिस केस the water content will decrease up to this level. So how much depth of water is decreasing? In case of can, this much of depth. Suppose it is wheat crop, this is the depth of decreasing. So in the next irrigation, when it will reach up to this point, in the next irrigation you have to apply this much of depth of water. Very simple. So now irrigation IW by CP ratio means irrigation water depth. IW CP means cumulative pan evaporation. So first of all you should know what do you mean by cumulative pan evaporation. Suppose आज तो मैं रिकॉर्ड कर रहा हूँ वीडियो. सपोज आज का डेट है तुम्हारा 27/2024 आज का अपना डेट है. तो दो डाटा चाहिए, वन इज डेली इवेपोरेशन एंड अदर इज क्यूमुलेटिव पान इवेपोरेशन. ओके, सो ये कहाँ पे मिलेगा? यू नो दैट देयर इज सम स्टैंडर्ड इवेपोरीमीटर. फॉर एग्जांपल यू नो USWB क्लास A pan evaporimeter. It is a standard evaporimeter and it is used mostly in Indian case. Okay, so suppose आज 27 डेट है, तो आज हम इरिगेशन कर दिए हैं, फील्ड में इरिगेशन दे दिए. तो आज हम क्या करेंगे? ऑब्जर्वेशन लेंगे. कहाँ से? ऑब्जर्वेटरी. कौन सा पानी इवेपोरेशन होगा? USWB क्लास A पानी इवेपोरीमीटर से हम क्या लेंगे? कितना इवेपोरेशन हो रहा है डेली. तो आज कितना इवेपोरेशन हुआ? सपोज आज का बहुत ड्राई क्लाइमेट है, बहुत हीटिंग इफेक्ट ऑफ द सनलाइट विल बी देयर. सपोज देयर विल बी 2 mm daily evaporation loss is there. In case of suppose tomorrow, that is 28 to 24, suppose there is less we can say less sunlight is there, less sunlight effect is there and 1 mm evaporation is there. Next day there will be 3 millimeter. That 3 millimeter means more hot climate will be there or dry climate will be there. Next day there will be suppose 2 mm evaporation will be there. So cumulative pan evaporation means go for successive addition of the daily evaporation. Suppose today the cumulative evaporation is only 2, but tomorrow it will be added. That is 3, 2 plus 1 3. Next cumulative 3 plus 3 6. Next cumulative 6 plus 2 is 8. So this is my cumulative pan evaporation data. So how to calculate? Suppose मैं एक example लेता हूँ. Suppose in case of, so here you can see rice, there is ideal CP ratio is 1.2. In case of rapeseed and mustard it is 0.7. In case of groundnut it is 0.6. Suppose हम example लेते हैं. IW by CP ratio, IW by CPE ratio for groundnut it is 0.6. Suppose हम आज मतलब today, suppose आज हम कितना पानी दिए हैं? Suppose I have irrigated 5 centimeter of water. किसको? ग्राउंडनट क्रॉप को. ओके, ग्राउंडनट को हम आज पानी दिए कितना? 5 सेंटीमीटर वाटर डेप्थ हम पानी दे दिए हैं. बट यू नो कि सर IW by CP ratio of groundnut is 0.6. If it is 0.6, you have to calculate here. Suppose IW by CPE for groundnut is 0.6. That implies you have applied 5 centimeter of water. CPE is equal to 0.6. So what is your CPE? CPE is equal to 5 by 0.6. That is 50 by 6. 50 by 6. And here the value will be suppose 7.8 8.3 something. Okay, suppose here the point is 8.3. Okay, ठीक है कि नहीं? आइडियल CP रेशियो इज इक्वल टू 0.6. पानी कितना दिया? 5 सेंटीमीटर पानी दिया है, तो 5 by CP इज इक्वल टू 0.6. CP इज इक्वल टू 5 by 0.6. So 50 by 6. So 6 8 is 48. 42 20. So 8.3. So here 8.3. पानी कितना दिए हैं? पानी दिए 5 सेंटीमीटर. पानी कितना दिए? 5 सेंटीमीटर. So here it will be 8.3 centimeter. So now my CPE is equal to, for this CPE is equal to 8.3 सेंटीमीटर. इसको अगर मिलीमीटर करें तो कितना होगा? 83 मिलीमीटर. ठीक है कि नहीं? So in this case you have the cumulative pani evaporation. Suppose it is in millimeter. Okay, 5 centimeter pani diye. Okay, so now suppose it is 83 millimeter. So now you have the cumulative pani evaporation. When it will reach 83 millimeter, you have to go for your next irrigation. So in this case you have to determine what is the value of this thing. Okay, so but if we will see another example, suppose I am taking rice crop. Suppose I have applied 5 centimeter of water and rice IW by Cp ratio is, in case of rice IW by Cp ratio is 1.2. You have applied how much water? 5. So Cpe is equal to 5 5 by, your Cp becomes 5 by 1.2. Then we can say 50 by 12. It is 50 by 12 means 4.1 point something. Okay, ठीक है. So 5 by 1.2 means 50 by 12. So 4.1 something. Okay, suppose 4.1 centimeter. 4.1 centimeter. If you will calculate into millimeter, it will becomes 41 millimeter. So this is for rice. Your so अभी देखो हमको we have taken two crops. One is rice, another is groundnut. As you have seen, groundnut के लिए हमको क्यूमुलेटिव पानी evaporation कितना चाहिए? अगर मिलीमीटर में होगा तो 83 millimeter, or we can say 8.3 centimeter. But in case of rice कितना क्यूमुलेटिव पानी evaporation कितना चाहिए? 41 millimeter or 4.1 centimeter. So now the question is, sir, which one will reach earlier? The cumulative pani evaporation 8.3 centimeter will reach earlier or 4.1 centimeter will reach earlier? Sir, 4.1 centimeter will reach earlier. Hence, as you know that you can say the IW by Cp ratio is more. If the IW by Cp ratio is more, then it is more moisture sensitive crop and the frequency of irrigation will be more. Okay, but if the IW by Cp ratio is less, we can say in this case it can sustain somewhat water stress condition and the frequency of irrigation will be less. Okay, so this is the IW by Cp ratio. You have to remember some of the data. Then coming to plant indices, as you know that if water content is decreasing in the soil, then obviously the water content in the plant will also decrease, because plant कहाँ से पानी लेगा? soil से पानी लेगा. अगर तुम्हारे soil में पानी नहीं है तो उसका मतलब plant में भी पानी नहीं होगा. If plant has less amount of water, then obviously the plant will show some symptom, which is called as the plant indices approach. So first one is visual symptom. क्या हम देख सकते हैं physically? So one is wilting हो जाएगा plant, पानी नहीं होगा, wilting symptom. Change in color, leaf का green होता है उसका yellow हो जाएगा. But it is somewhat difficult to measure whether it is because of the water stress or because of the nutrition deficiency, because आपको पता है कि नाइट्रोजन डेफिशिएंसी होगा तो लीफ भी कलर चेंज हो जाएगा, ग्रीन से येलो हो जाएगा. तो ये जो डेफिशिएंसी चेंज हुआ, जो कलर चेंज हुआ, ये किसके कारण हुआ? डेफिशिएंसी ऑफ न्यूट्रिएंट और डेफिशिएंसी ऑफ मॉइस्चर. यू कैन नॉट डिसाइड. सो स्टिल द चेंज इन कलर यू कैन कंसिडर इट. देन विजुअल सिम्टम और क्या आएगा? ड्रॉपिंग ऑफ लीव्स, रोलिंग ऑफ द लीव्स, कर्लिंग ऑफ द लीव्स. एज यू नो दैट इफ सॉइल में पानी नहीं है एंड उसका मतलब प्लांट में भी पानी नहीं होगा. सो यू नो दैट द प्लांट हैज ए एबिलिटी, plant that is called as the adaptation ability, adaptability. Okay, so if you have soil moisture stress condition, plant has to give something that is which is called as adaptability or adaptation. So in this case, the plant will try to drop or shed its leaves. Why? Leaf shedding will be there because it will try to reduce the transpiration loss of water in order to conserve the soil moisture. Curling of the leaves, rolling of the leaves, and these are all methods to decrease the transpiration of loss, so that soil में क्या होगा, moisture conserve होगा and plant can survive for some more duration. Okay, so one is visual symptom. Second one, plant water content and water potential approach. आपको पता है अगर सॉइल में पानी नहीं है तो प्लांट में भी पानी नहीं होगा. सो रिलेटिव लीफ वाटर कंटेंट विल डिक्रीज, लीफ वाटर पोटेंशियल विल डिक्रीज. Very simple. Then coming to leaf diffusion resistance. Resistance to water diffusion if water stress will increase. Diffusion means what? As you know that transpiration is a which process? Transpiration is a diffusion process. And transpiration कहाँ से जाएगा? Transpiration leaf से कहाँ पे जाएगा? Atmosphere तक जाएगा. This is the transpiration, which is a diffusion process by which the water is lost from the leaf to the atmosphere. This is which process? This is a diffusion process. But अगर plant में पानी नहीं होगा तो now the plant will try to reduce the transpiration loss by increasing the resistance of diffusion. Resist करेगा वो diffusion process को. So leaf diffusion resistance will increase if the plant is under water stress. The next one is canopy or leaf temperature, that is TC. Canopy or leaf temperature, you know the transpiration is a cooling effect, you know that, and transpiration is called as necessary evil, and this transpiration most important is for cooling effect. That means अगर transpiration हो रहा है तो प्लांट का टेम्परेचर क्या होगा, लेस होगा एज कम्पेयर टू एटमॉस्फेयर टेम्परेचर, बिकॉज प्लांट कूल हो जाएगा. बट इफ सॉइल हैज लेस वाटर, दैट मीन्स प्लांट हैज लेस वाटर, अगर प्लांट में पानी नहीं होगा तो ट्रांसपिरेशन लॉस क्या होगा, नहीं होगा. दैट मीन्स इफ वाटर कंटेंट इन द प्लांट इज लेस, सो ट्रांसपिरेशन इज hampered or transpiration process is affected. That means cooling process is affected. So plant का canopy temperature क्या हो जाएगा, increase हो जाएगा as compared to atmosphere temperature. So in this case we have to maintain or you have to measure the difference in temperature or the change in temperature between canopy temperature and atmospheric temperature. This is temperature canopy or temperature of leaf, and this is the atmospheric temperature. If transpiration is high, that means cooling effect is there, that means the crop or canopy temperature is less than that of the atmospheric temperature, then the difference will be negative. So if the difference will be negative, so you know that there will be sufficient of water is present in the plant, hence the canopy temperature is less because of the cooling effect of transpiration. But if the canopy temperature and atmosphere temperature will become zero, then this is the point where water stress will start, because transpiration will decrease and the temperature of canopy temperature will increase and it becomes equal to atmosphere temperature. Okay, and this is called as the stress degree day, and it is the summation of Tc minus Ta, stress degree day. Then coming, assume there is a question that the canopy or leaf temperature is measured by infrared thermometer. This is measured by infrared thermometer. Then coming to critical growth stages approach. ये बहुत प्रैक्टिकल अप्रोच है, मतलब फार्मर के लिए. ये सब नहीं पता फार्मर को, तो फार्मर क्या करेगा, फार्मर करेगा कि मुझे क्या चाहिए, क्रिटिकल ग्रोथ स्टेजेस चाहिए. द क्रिटिकल ग्रोथ स्टेजेस मीन्स एट व्हिच स्टेज यू हैव टू अप्लाई वाटर. इट मीन्स at this stage plant require more amount of water. If you are not applying irrigation at this stage, the plant growth or the plant yield is highly affected. Okay, so now for example rice, the tillering stage, panicle initiation stage, flowering stage, these are the critical growth stages. For wheat, crown root initiation, CRI stage, we can say mostly asked in the examination, which one is the most critical stage of wheat, that is CRI, crown root initiation. Then coming to jointing stage, milking stage. For example green gram, there is flowering stage and pod formation stage. Okay, so now these are the different methods. At last finally, for very simple techniques are there, the farmers can approach all these things. One is other simple technique. First one is soil कम sand manipulate technique. तो soil भी होगा, sand भी होगा. अच्छा, बट फील्ड में तो ऐसा नहीं होता है ना, तो नॉर्मल टेक्सचर होता है. बट इधर हम क्या करेंगे, जो फील्ड है, जो मेरा फील्ड है ना, उसके मिडिल में, so in the middle of the field we will make a pit, or we will dig out some soils of which size 1 meter cube size. That means 1 meter cube length, 1 meter cube width and 1 meter depth. So 1 meter cube का soil क्या करेंगे हम, dig out करेंगे. So we will make a pit of 1 meter cube and take out the soil, and whatever the soil is there you have to add 5% sand by volume. हम इसको क्या करेंगे, जो soil लाए हैं उसमें 5% sand मिला के फिर क्या करेंगे, refill कर देंगे उसी में, जहाँ पे जो pit था उसी में refill करेंगे according to the natural order. तो सर हम ये क्या कर रहे हैं, why we are adding 5% sand by volume? Because as you know that if we are adding sand, that means you are increasing the sand proportion of the soil. So if you are increasing the sand proportion, you are increasing the macro porosity. Which pore? Macro pore. And as you know that if sand is there, so macro pore content is more as compared to the, so in this case the sand will be present, so the macro pore content will be more as compared to the surrounding field. So now suppose today we have applied irrigation, and you know that day by day the water content will decreasing. But you know that as you have added sand in this middle portion of the field, so in this case the decrease of water or the loss of water in the soil is very quick. So अगर इधर क्या होगा, so loss of water is more quicker as compared to the surrounding field because of sand is present, because the gravitational water will be there, or macro pore content is more because of force of gravity, more amount of water will go downward. So the loss of water is more quicker in case of this pit region as compared to the surrounding field. So in this case what you should do, so in this case you know that if water content is decreasing rapidly, so whatever the crops present here in this pit or in the middle portion of this field, whatever the crops are there, they will show initial wilting symptom. So in this case, if the middle portion of the field where you have refilled the sand, the plants will show earlier symptom, wilting symptom, in this time you have to apply your next irrigation stage. The same method, same principle is there. Second one is high seed rate. तो इसमें क्या होता है, अगर तुम्हारा एक सरफेस और फील्ड है, जो कि हायर एलिवेशन, दिस पॉइंट इज माई हायर एलिवेशन है, जो समवट अपर लेवल में होगा. सपोज ये वाला फील्ड है, ये हो गया तुम्हारा हाई एलिवेशन साइड. सो इन दिस एज यू नो दैट अगर हम पानी दे रहे, इरिगेशन दे रहे, पानी कहाँ पे जाएगा, पानी फ्रॉम द वाटर विल मूव फ्रॉम हायर एलिवेशन टू लोअर साइड. This is higher valley, this is lower valley. So that means water will stagnate here. The water logging condition may be occur in this case, but here the water will drain out very easily because of runoff loss. Okay. So in this upper elevation layer, we will do? We will increase the plant population by 4 times. 4 times we will increase the plant population, or plant density is how much time more? 4 times more. Where? In my upper portion of the field or upper elevation of the field. तो इसमें क्या होगा, वेरी सिंपल सर. अगर प्लांट डेंसिटी इस जो एरिया में, ये ऑल्सो इज ऑल्सो 1 मीटर स्क्वायर एरिया, अपर एलिवेशन में 1 मीटर स्क्वायर एरिया लेंगे, उसमें प्लांटिंग डेंसिटी 4 टाइम्स इंक्रीज कर देंगे. तो क्या होगा सर, if we are increasing the plant population, obviously the plant water uptake will be high as compared to the other plots or other fields. And in this case more loss of water will be there in the soil, because more amount of transpiration loss is there because of high population. So now as compared to the other crops, these crops will start giving earlier symptom, because इसमें जो soil में पानी होगा वो क्या हो गया, the water content in the soil is decreasing very quickly because of more transpiration loss of this high population. And this population will give earlier wilting symptom, and this is the time to irrigate my field. Very simple. And the last one is field and appearance method. This method is based upon the practical experience of the farmer. Suppose the soil contain more moisture. If the soil contains enough moisture, then I can fill it and I want to make it a bulb, soil bulb. I can form a soil ball or anything which is field and appearance method. There are different criteria of different soil moisture content and what you can make. Either you can make a ball or you can make a ribbon. Based upon these things you will schedule your next irrigation. Okay, so I think this is the very in a very simple way you will understand what is the criteria of scheduling irrigation. हम कब पानी देंगे, when to irrigate, and in some cases like IWSP ratio, K per perimeter, you can also find out the amount of water to be irrigated. Okay, thank you.